Hello friends, सबको नमस्ते. Today in this video we will create a brain tumor classification model, and this is going to be an end-to-end project. We can also deploy the project using a web app, and the framework which we use here is Streamlit for the deployment. So let me first show you the dataset how it's look like. It basically contains two folder, test and train, and in train it has two class. You can say two classes where it's saying yes or no. Means yes here is a scans, it can be a CT scan or MRI scan. It contain tumor in it. Okay, brain tumor means brain scan with tumor. Okay, so this spot here, it's a brain tumor in it. Okay, so it contained to and the second folder is no, where scan of a brain with it can, you can say it is a normal scan. Okay, of a brain. So two classes will be there, and same for the test. Two folder, yes and no, containing for brain tumor scans with the classes, and same for the test. Okay, so this is our brain tumor data set, and this is a Jupyter file which I will explain you line by line to download the model so that we can use it in a project using a Streamlit and deploy it. Okay, so let's get started. I will open this in Google Colab because my Lappy GPU is not that much good. So let me open it. So this is a Jupyter file. Let me first show you how we can connect the dataset which is uploaded in your Google Drive to your Jupyter file. See, this is my dataset which I uploaded in my Google Drive. Let me share this. Okay. Anyone with the link, copy link and paste it here. Okay, you have to copy this thing from here till here. You can say this is a unique ID of your file. Copy this and paste it here in place of this whole thing. Okay, your data set which is uploaded in your Google Drive is connected with your Jupyter file. So let me run this. It download the dataset in a zip way. Okay, you can see it. See, in a zip file. Now I have to unzip it. Now you can say this is all the libraries which we use for the creating the models, or we can say downloading the model, best model. Okay, you know that NumPy for the calculation, pandas for the data frame. Okay, and import is Keras, for the layers. Here layers is there, plottation, splitting. Since we do not have a validation folder, we have to use a train images only for the validation. That's why ImageDataGenerator for data augmentation, you can say. These are the layers which we use for the creating the model. Sequential, you can say the architecture of our layers will be in a sequential way. Learning graded model checkpoint, these are the two functionalities which we use for callback functionalities. Okay, this the auto optimizer to update the weights. Let me run it. These are the two directories which we use, train directory and test directory. Okay, now here we generate the data loaders, okay, which we use for training and testing. So why I am using this image data generator? This is because we do not have enough images, you can say even number of images for brain tumor and no brain tumor, two classes will there. That's why. So to avoid the overfitting, we have to use data augmentation and other methods for avoiding the overfitting, so that our model will get the best accuracy. Okay, that's why. And one more thing, data augmentation is the best way because it's give us a chance, or we can say give the variety of the images, provide varieties of the images, so that the model will get robustness, increase robustness, and increase the accuracy and reduce the loss. So that's why here just we have to normalize the pixels values first. Set validation this way. Here set validation split. Why I'm using this? Because We do not have a validation folder, or we can say validation images. We from train directory only we have to produce the validation data set. 0.2 here means 20% is for the validation. 20% images will go for the validation data loader. Okay, rotation is there, width shift range is there, random vertical shift is there, random shared transformation is there, random zoom is there. This all are the things which is used for the producing the in more images. Okay, for you can say variety of the images, horizontal flip and flip nearest will be more will be nearest means if suppose we rotate the images, or we can say we shift the images to right side. So the portion which is shifted of is the portion which is remain empty will that empty you can say that empty space will be filled with the nearest pixel values. Okay, whether it is white or whether it is black. Okay, this is the things. So here it's first image data generator. You can say it create the object here with data augmentations. Now using that data augmentation object, we flow from directory. Oh, one more thing I want to tell you. Let me open my dataset. Say this is a dataset. For using this flow from directory, you have to create then we have to that number of classes we have two, yes or no. So there, that's why you have to create two folder. The you can say the more the number of classes you have, the more folder you have to create it according to that only. And according to that only, you have to upload the images on that particular folder so that you can use flow from directory method for creating a data loader. Okay. So this way flow from directory, it automatically, you do not have to define that for yes which index value you have to give it. Automatically define it. Okay, so don't worry about that. We are using here flow from directory. We have to pass train directory from where it upload the images, and the size you have to resize the each and every image according to in one shape, 224 batch size will be 32, and color mode is grayscale. Why I'm using color mode grayscale here? Because for increasing data augmentations, sorry, not increasing, so to increase the speed of the computation, because grayscale have only one channel, so computation speed will increases, and that's why training speed will be get increases. Okay, and also there is no need of RGB, because all skins is in white and gray format. Okay, so that's why grayscale is best for that. And why I am using here categorical? Because we have two classes, yes and no. That's why I am using categorical here. Otherwise I will use binary. Shuffle true means it will shuffle the images. Okay, same way for validation, but we have to produce images from the train director only. So that's why we have to use train directly. It automatically give me 20% of images in the val data variable. Okay, with same batch sizes, girl mode, categorical, true, shuffle true. Okay, let me run it. It's completed. See, to know, NVIDIA has said you that flow from directly automatically defined. We do not have to manually define that which class belong to which index value. So that's why, to know that which class is belong to which index value, we have to use this. Okay, we have to use this function. Okay, otherwise you will get confused. Or when you can plot the images. So for 0 it is saying no, so for 0 we are saying no brain tumor. For 1 it's saying yes, so that's why we have to produce 1 for brain tumor, means particular image contain brain tumor here. Now we have to iterate over it, and one let me show you the one important thing, so to get more clear about that. Print train data, so not test data, val data. Okay, let me do it. See, 113 and 113 means there is 113 batches which contain 32 images. Okay. Let me create the code for displaying how many number of images for the brain tumor and how number of images for the no brain tumor. Let me pause the video and code for that. Okay. Wait for a minute. Say this. First, I list all the images file name in one of the variable to brain tumor with no brain tumor images, brain tumor with yes folder. Okay, so that's why OLS directory, OS path join, brain train directory, and with no folder, brain directory yes folder. This way, I get to one list where values will be length of the brain tumor images and length of the brain tumor yes images. Okay, and these are the labels: no brain tumor and brain tumor. Okay, and after that I plot the bar graph, plot the bar, labels will be this, values will be this. Okay, color will be blue and green, x label will be categories, y label will be values, bar graph for given data. Say this: no brain tumor number of images will be 175, around 175 or more than that, and same for the brain tumor, more than that or 175. Okay, so we have, you can say that for training purposes, for brain tumor number of images we have 175, and no brain tumor means 1750. Okay, so this way we plot the bar graph so that we can know how many number of images we have. Okay, it give us a clear picture. See this here, length is one train data for, and validation data is 130 means 113 batches will be there with you can say in each batch it contain 32 number of images. Okay, now we have to iterate over it. Next, train data, images and labels. Here first it can generate the iterator for that, and after that we have to use next for iterator. Level or shape, I will show you what this plot.xs fig for fig basically represent the entire plot where subplots will be plotted. Axis where is used for the iteration over the subplot, but before label it is in a 2D dimensions. And here 4 by 4 means 4 rows and 4 columns. Each size will be of the subplot will 22 to 22. Access dot label will convert 2D dimension to 1D dimension. Why we are converting it? Because we want to get ease of iteration. Now it's moved to I order 16, means 16 subplots will be there. I am so. See here we are using grayscale, but that's the default values of I am so for plotting for matplotlib is Viridius. I think Viridius or something. Let me show you. Yes, Viridius. Okay. Default values of CMap is this way is the images look like in Viridius format. So we don't want this that way. So to map the, you can say map the scale or color scale, we have to use here gray. Otherwise it will show you is in a Viridius format of a image and you will get confused that why it's showing that type of images. Okay. Now our and with the argument labels dots I basically in labels here, labels is containing this label variable containing 32 labels, 32 images label. So we have to iterate over it also same way for the images. And when we iterate over it, our np dot argument max, because here labels you can say when suppose it's we are I'm plotting about it, I'm plotting on it. So see here each label, suppose for first image first image label will be the 0 and 1. Here 0 index, on 0 index the value is 0, and for the one on a 1 index the value will be 1. And let me show you one difference. See here, no brain tumor. Here 0 index value, on 0 index value the value is 1, and 1 index value is 0. So this way the label is defined. So to get the index value on which the maximum value is present, we use an argument max. It basically give me the index value on which the maximum value is present. Okay, on and you know that when we create this class label here, basically 0 and 1 define the index values. Okay, on which the maximum value is present, and it define on which the maximum value is present, it means that particular index representing that particular class. Okay, that's why to get the index value why we are getting it. So let me run it. Let me run before using this. Okay, see map gray. so that you will get to know what I'm telling to you, what I'm trying to tell to you. See, this way it show the image and you will get confused that why it is showing me this type of this color scale images. Okay, now let me see, map is equal to gray. Now it show me color format of images. See, okay, this way flipping will be there, and see, it's filling that's it's see, it's rotate the images and filled the values or empty values with the nearest, you can say nearest pixel values. This way it's worked. Okay, and these all the images are the color scale oh sorry, you can say data augmentation images. Varieties of the images got increased. No brain tumor means, see what decided, zero index value will represent no brain tumor, no brain tumor. Okay, it means on zero index value maximum value will present. See, one present on zero index, no one one. See here, this it contained the brain tumor. Say this is a brain tumor, and what for the images where which represent a brain tumor, one index value should have a maximum value. So this one index value should have a one here maximum value. This way we have to see how the labels look like, so that we do not get confused. Now we have to create our model. Okay, see, input size which we are using here to 24 to 21 one here, one channel, because we are using one grayscale images, and here we want the architecture of a CRM model will be a sequential. Okay, this is the first layer where we are passing one first layer will be convolution layer with 16 filter, and 3 by 3 will be the size of each filter. We are using ReLU activation function. Why we are using activation function? Because activation function, because add non-linearity in the model. Adding non-linearity means it learn complex pattern in the data sets. Okay, if you do not use any activation function, so non-linearity will not be added, and our model will act as a linear model. Okay, so it will not learn complex patterns. That's why we are using activation function ReLU basically. If suppose any value in any value is negative value, so replace that negative value to 0. If suppose any value is greater than 0 value, remain that value as it is. And shape will be input size this way. And batch normalization. Why we are using batch normalization here? Suppose this is a feature map. After using this convolutional, we get a feature map like this: 1, 2, 3, 4, 5. After using the batch normalization, its value is converted to this way. Means its value decreases. So this way, two things happens. You can say one thing is that each feature no one feature will get dominated towards the other feature. All features will act as equally. Okay, second thing, computation speed increases. That's why we're using batch normalization here. And max pooling basically, you can say, decrease the dimension of the feature map. And window size which we're using here in a feature window max pooling is 2 by 2. Let me show you what is max pooling layer, so that you get clear picture about it. Max pooling layer. See here. See here, we are using 2 by 2 max pooling here. It will go first here. Okay, it will see 12. What is the maximum value in this grid? Okay, so maximum value is 20, so it will do 20 will be there. Then this 30, 30. Now one more thing I want to say you, that here, see here, what is the value of stride here? It is not defined. Okay, so say this. It says if none, it will default to pool size. So what is the size of pool size? 2 by 2 means here stride value is 2 by 2. Let me show you what is the use of a stride. Which is what which pictures? Let me see this, show you this. See, here stride 1, see if the stride is 1, it will shift only one, you can say one column, okay, one column to the right is, and one column, one row from the above. Okay, this way stride work means it's shift to the right side one, shift to the right side one column to one column, one column, and from the above also one row, one row. And if stride value is 2, it will shift the right side to 2 column. With one, after one computation, it will shift to right side 2 column, and from the above 2 column if the computation of previous is completed. Okay, this way it's work. Say this, shifted to right side 1, so one column will be skipped, and this way it's work. And here, if stride value is 2, 2 column is skipped, and from the above 2 rows is skipped after computation. Okay, this way it's work. Basically, the use of this feature map is to reduce the dimension of the feature map. Okay, and one more reason that it also acts as robust, no, because most of the images, you can say shifting will be get accuracy. Same way, second layer will 64 filters with 3 by 3, and activation is ReLU, and batch normalization, pool size 2 by 2. Third layer, same convolution, 128 filters, just increasing the number of filters after each in every layer. It is not necessary that you have to increase the number of filters at every layer. It's up to you that you can either cap each 64 filter here, 64 filter here, 64 filter here. It's up to you. You have to try hit and trial methods. Okay, I have hit and trial methods, and after many of your training, I've decided to use this stuff this way. It's up to you how to you have to place the models, or you can say place the number of filters in each layer. And after flatten, we have to using dense layers 1024. Okay, activation ReLU here, also vibration normalization, 256 number of neurons, 128 number of neurons, and last layer contain 2. Why here it is 2? Because we have 2 number of classes, no brain tumor and brain tumor. That's why. And why I'm using activation is here softmax instead of ReLU, because softmax convert the neurons values in a probabilities values, and when you add this 2 number of neurons probabilities value, you will get 1. Okay, that's why basically probabilities value can act as a percentage, that how many percentage a particular image belong to that particular number of neuron, or you can say class. The activation function, sorry, not activation, the optimizer here we using here is Adam. Learning rate will be 0.008. You have to precisely, or you can say very hit and run trial method, you have to select a learning rate, because learning rate, if it is too low, then training time will get over, and you will not get does not get any very good accuracy. Okay, and if it is too high, we can easy that we can skip the global mean which we try to achieve during training. Okay, and categorical cross entropy, you know why we are using here, because we have 2 number of classes. That's why. If we have only 1 number of classes, we use binary here. Okay, that's why categorical cross entropy optimizer error. For evaluation, we use accuracy matrix and model summary. Let's run it. See, these are the output shape of each layer: 2, 22, 16, number of filters, and 2. Now, this is a model checkpoints. What is the model checkpoints? Basically, it saved the model during training. Best model. Model.Keras, you can say this is the path where we save the model, and it's evaluate for saving the model, which what thing you can say, which matrix this model checkpoint had to see. It's see validation accuracy, means where only the validation accuracy is high from the previous validation accuracy, it will save that model. Okay, mod means max, means see the maximum of the validation accuracy. Say best only means suppose epoch 5 validation accuracy is you can say 50, and epoch 10 validation accuracy is you can say 90, so it will replace the previous model with that model and save particular that past model where validation is maximum. Verbose 1, what is the use of verbose 1 here? Means it display the masses. If suppose it display the masses that which model is saved by the model checkpoint, okay, with which accuracy, means it display the masses. If suppose verbose one we will not use this attribute, so it will not display the masses during training, and we will get confused that which model is saved which model is not saved. Here learning rate scheduler. This way we schedule the learning rate at after every you can say after every epoch, okay, with cosine annealing. Here I am using this cosine annealing for learning rate. Learning rate schedulable, this function will get activated 0.1 into 0.5 into epoch into tran. Okay, this way learning rate scheduler means it's basically either increase the learning rate or decrease the learning rate during the epoch according to the function which we use. Okay, it's depend on us that how we have to control that learning rate. So for controlling, I'm using is cosine annealing. Now, how many epochs I want? 30 epochs I want. Body dot point, train data I am giving. Callback functionalities. Two functionalities I am using here for callbacks. Model checkpoints and learning rate scheduler. Validation data, valid data. Epoch and epochs. Number of epochs which I am using is 30. Let me run it. Oh, sorry. I am not run this. It will throw me the error. Let me run it. So training is got started. Let me explain you these things. Here I am plotting the, you can say, plotting validation accuracy and validation issue so that we get a clear picture about that. Your figure is 8.8.2. History by history.here. History is variable based saving each thing. Validation accuracy, validation accuracy, validation loss, training accuracy, training loss. That's all things are saved in history variable. History.history accuracy, validation accuracy level. See, this way we fetch the information. History.history accuracy. Here accuracy is training accuracy. Label training accuracy. We are what giving it color blue. Validation accuracy. History.history validation accuracy. Number of arrange. Here see what is the meaning of arrange here. Arrange basically this is x tick means this thing 0.1. These are the things started from for x string. It start for the 5, and epoch plus 1 means how many epochs? 30 plus 1. 31 will not get included, but 30 get included. See, 30 get included, 31 will not get included. Okay, and what is the difference? We can say 5 and 30. From 5 to 30, what is the difference between that? It will be you can say it will be 5 difference. See, 5 10 difference is 5. Same way for the y stake 0 1.5 and difference will be 0.1. X label and oh sorry, same way. See, I am explaining this thing and I get here. Okay, but the thing is same only, so don't get confused. And X label epoch accuracy training accuracy and legend, because we want legend sub so that we does not get confused that which line belongs to which label. Okay, so that's why grid true. So this way it's showing the graph. Now we have to check our model, shape model, how it's getting how prediction how it is predicting the images on unseen data set. Okay, here we are using random here. Okay, we have to load the model, Keras Keras.model load model. It will load the model. Already explained this to line. What is the meaning of class name? I have already explained you. There's a time state directory. Here it is list directory because it contains all the images name in this. Okay. Basically it contains the folder no or yes folder name only. Okay, now we have to select random folder name. After selecting the random folder name, whether it is yes or no, we have to select list all the directories in that file name, because now this test directory file name basically contain all the images name in that particular folder we have which we have selected randomly, whether it is yes or no. After that we have to create image path. Now OS path, just give me the text directory yes or no. This is a variable. After that we have to randomly choose the file name. Okay, so that iteration will not be you can continuously, it will be random iteration will be there. So that the why I'm is using this, because I want to display the images from both the folders. Now, let me show you one more thing. I want to say that with what all the pre-processing which you have done before the training on the images has to be performed after the after training, when you will have to use that model for the prediction. What all the things we have done? First, we have to open this. We have used grayscale image. Now we have to convert this in MP array image, because we have to expand the dimension, because on training we are sending the images in batches. Okay, so model basically accept the batch image only, but we are sending the single image here, so we have to expand the dimension. Now here dimension, you can say it becomes uh, one batch for the batch, zero मतलब channel will be one, and 224 into 224, this way it's converted. And before conversion, its dimension is like this. Dimension is like look like this. So this way it convert the dimension. Why I will tell you why we are converting it, because during training we are sending the images in batches, so that same dimension it will our model will accept. Now input of expand dimension image parade x is 0, it will expand a dimension 124. Okay, now what all the things we have done, we have to convert the image in grayscale. Second, expand the dimension. And third, normalize the pixels values. Now here it's we normalize the pixel values. This all the things had done which we have done before training on the images had done now here for the testing. Now we will not get you have a question that we have also applied the data augmentations, this flopping, cropping, this all things. This thing is applied during training on the images only. This thing will just you can say just increase the data set. But what all things would you have to perform on one image only? That important things is normalization, grayscale, and expand dimension. This thing is important. Okay, you can skip that augmentation part, that rotating or skipping. But one thing I want to show you, that during data augmentation only, we are normalizing the pixels value. Okay, see here. Skip all this part. Just skip during testing. Just skip all this, or you using predict model. You can skip this all thing till here. But you have to use this normalizing pixel images because it's important. Okay, we have performed all this pre-processing. Now image model.predict image, we have to pass the images. And why using zero grid? Because you can see when we pass the batches, number of 32 batches, it give me the output of the it will give me the output of the 32 images. But here we are passing just one images, so to get the data of the one images, we are using zero for fetching the output of one images only, because we are giving only one images, not the batches of images of 32 or 2 images. That's why. Now np.argument x, I already told you that because it gave me the index value on which the maximum value present, and maximum value defined that particular image belong to which class. And put down round here prediction print index, because the value present on that particular index will be the maximum value, and that maximum value act as a score, you can say act as a percentage score. Here rounding before, and after that we are multiplying it with 100. Now actual index means class name. I put a argument max. Sorry, not here, not actual index. Actual index is basically giving me what I want to show you. Let me show you one thing. Sorry friend, this line is extra. Let me reduce it. Now it's predict the predictions. See how prediction look like. See how it look like. It's giving me the values. 53%, 56%. It belongs to that index value. 43% particularly belong to this index value. Okay, this way the prediction look like, and we have to get the maximum value, index value on which the maximum value is present. We are using an argument max. It will give me this value, and we have to score. Here score means that this value 0.56 and 0.43, these are the score values, you can say probabilities. So to fetch this value, we are using np round pred index में, because it will give me the index value. Okay. Now, and so you can say why I'm using the CPAP, because for matching the formats. Now prediction, class name, pred index. Here we are plotting the images with class name. Here label, basically here it is predicted, means prediction by the model. Here actual label is this, means what is the label. This actual label decided by the folder name, because we are uploading the image with a uploading the image in a folder with a class name itself. So at test directory folder, see here, test directory folder, give me the folder name on which the image is present, and test directory folder, it act as a class name. Okay, that's why we are placing a test directory folder. Score will be score. Let me see how our training goes giving. See, saving model with model.keras. Validation improves from 96 to 97, saving model to model.keras. Okay, this way. See, if I will not use verbose one here, this message will not get display, and we will get confused which model is saved with validation accuracy. Okay. So let me come after this training got completed. Okay. So our training got over. Last model which is saved is this one, last epoch 30 with a validation accuracy. You can see 98 accuracy we achieved. It's going to be good model. Okay, these are the you can say graphs after training. Okay, and these are the predictions, you can say, after model is you can say trained. See, no brain, no. Let me see how many predictions are wrong. Till now, this prediction is wrong. Label is no, means actually it is have no brain tumor, but it's saying having brain tumor. So this thing is wrong. And the brain tumor, brain tumor, brain tumor, brain tumor. See, only in 16 images, one image is wrong, one prediction is wrong. Okay, all predictions are correct. So let me download this model so that I can, you can say, I can use it in my Streamlit and make a web app and deploy that. Okay, it's downloaded. Let me see. No, it's not yet downloaded. See, it's downloading. Okay, so let me download this model and come back in a directory with the model and this Jupyter file, and we will make a Streamlit and deploy that. Okay, so let me pause this video. So this is a directory. We have a model and a brain tumor Jupyter file and a requirements. So let me open this in a VSCode. So this is the requirements which we need for you can say for our model. Let me first create a virtual environment. Our virtual environment is ready. Let me activate that. It's get activated. Let me download the requirement file. Okay. This is a state, you can say command. Till it's downloading, let me create the architecture of our directory. Okay, the folders which is required. First folder will be model, Okay, second is a, you can say, classifier, which is used for classifying. Okay, and the third is utils. Okay, now, oh sorry, cap this two things, not these two things, this two in a model. Okay, let me create one main file where I will code for the Streamlit. Let me code all the things, all the codes which is required for the Streamlit, so that I can explain you each and every line by line, and what's the use of that code, why we am writing that. Okay, so that you will not get confused. Okay, I will code for the classifier, I will code for the utils, I will code for the models, each and every line. And after coding, I will explain you each and everything with the full detail, each and everything with the line by line, so that you will not get confused. So let me code that and come back with the video. Okay. So this is our Streamlit code. Okay. So let me explain you. This is a Streamlit which is required. This is set background from utils. From utils, basically this folder, and its folder, it contains a set background function in a util.py file. How we can fetch the function, or we can say import the function from this util.py file into the main file, is one having a, it is you can say it, there is a one way. Let me first, you have to util.py file, create the function. This function is basically set a background of your Streamlit. Okay, after creating this util.py file and function, you have to create this ini.it, this file, init file. In this init file, from .util here we from .util, basically describing the this util file. After that, you will import this set background. This thing is over. You now go to the main file, just type utils, from utils import set background. Simply it will import the function without you can say without describing the path of your Python file where this function is there. So what is step, I will explain you again. Create a util file, create a set background file, create this init file, uh, from .util import set background function. And in the main file, how you can import, just from utils, the folder, import set background. This much is easy to go. Okay, let me see why it's throwing me this Streamlit error. I think so environment is not activated. Let me download the requirements file. So I think so is everything will be resolved or solved. Okay, before that I can explain you each everything. See, okay, one thing is over, utils part is over now. Let me close this. Okay, now this is the config. You can say the tab title, it is this tab title. To display the tab title, what will be the page title, you can say tab title will be this. Layout will be centered, means everything should be centered. And this is a background, this is a function which we using, set background. It will from utils, it will let me show you the background which we are using. See, so this is a background. Okay, now this is the, you can say this is the css for the you can say for the header and for the title. Okay, so these are the css. I will not explain you this, but for to display the css, for you can say, so to activate the css, we use this function markdown and unsafe allow html true. Okay, now using this html markdown, just give you the tag class. Here class will act as this title and Brain Tumor Classification, and unsafe allowed HTML, same for this header. Okay. Now st file uploader, basically it is used to upload the file, okay, which we want to upload. And here this empty is act as a key. You can say I don't want to display the message above the uploader, like upload the image, upload this. I want or does not want to display that message. So I am giving this value empty. Okay. And the type which we want to upload is JPG, JPEG, JPNG, and JFFI. These are the images extension which we want. Okay. And here this file, basically the after uploading the file will save it here. Now here we are loading the model. Keras.model load model, the model which is present in this model dot this model dot keras. Okay, we are uploading, and these are the class name. If suppose file my by using this here, because suppose we when someone click on the uploader and does not upload anything, so that's why, otherwise it will throw an error. That's why if file is not known, image will now image will convert to RGB. Now you will get confused why I am converting the image into RGB. What we are using in model, we are using in grayscale. But don't worry, we will convert our image into RGB in this function classifier dot a classifier function which is present in this classifier. Okay, this classifier function I will explain you this, don't worry. Okay, so here I am passing two things: image, model, class name. Class name will be this, image is this, model is this. Okay, and output of this classifier function is two things: prediction and score. Prediction is basically give me the class name, and score basically a probability. Okay, so let me explain you this, how we importing the classifier function. See, from classifier means from this classifier folder, import classifier function. Now classifier function is present in this classifier.py file. Now see, classifier.py in py file contain classifier function. Okay, so to import this function in the main file, we are using .init.py file. We have to make this init.py file. It will import classifier function from classifier, and after that we just directly we have to import function from classifier function. This is this is the folder name, and this is the function name. And here you can say this is a Python file name, and the function which is contained by this Python file name. Okay, so let me explain you. After getting the image and the class name, pre-processing is required. I already told you what all the pre-things which we perform on an image before training had to perform on a testing time also. So we have to convert the image in grayscale, expand the dimension. I already told you what is the use of expanding the dimension, and the normalization of the image. After pre-processing, just pass the image. We have to just predict the prediction of the image, pre-process image, and 0. Why we are using here 0? Because we want the data of the first image as a expansion, as a image dimension expanded. It acts as a batch in which one batch is present and one image is present. So to get a data of that image, we have to use this 0 index value. Now argument max basically give me the index value on which the maximum value is present. Maximum value means represent the probability. Okay, and this here I am the getting the score. Now after using this after, see here I am first getting the score. After getting the score, I am rounding it to 4 values. After rounding it, you can see that let me show you so that you will get a clear picture of that. See, this, the scores values is in a 0.01. To get the actual score, we have to multiply it with 100. Okay, and round off to 4. After rounding, even after rounding, it is in a you can say float value. To convert it in an integer value, we are using int here. Now we get the class name and just pass the label and score. Okay, let me come back to the main file. Okay, after getting the prediction and a label, this is the way. This 3 line is just to convert the image into the format that in the format that we can display it in a web app. Okay, we cannot directly display the image to the web app. We have to convert it. So to convert, for the conversion, we have to use this three lines. Okay, now here we are just displaying the predictions. First image prediction, displaying the image, then the prediction and the score. So this thing is over. Nested code is over. Let me run it. Okay. Let me run it. To run the Streamlit file, you have to use this command. Okay. It will open my web browser. So this is our interface. Let me choose one image so that we can get. Let me choose one image from no. Let me choose this image. See how it's working. See, it's image, how it's display the images. No brain tumor. Yes, correct. Prediction is correct. Let me choose one image from the brain tumor. Okay, from the yes folder. Let me choose this one. Open. See, brain tumor 99%. So our model is ready to deploy. Create your GitHub repository, okay, and upload all the files one by one. I already created it, so I will not do it again. Let me choose this one. Okay, so one by one upload all the files like this. Model, 2 files, model and a Jupyter file. Okay, main, classifier, 2 files, init and classifier. Don't forget to upload this, because this is a main file to upload the function in a main file. Okay, utils, background and init. This is a main file. Let me go to the Streamlit cloud. Streamlit cloud. Go to this login here. I already logged in here. Okay, so I will not do it again. You will after logging, you will get this type of interface, and go to your GitHub. What GitHub repository you want to deploy? Brain tumor. Give your Jupyter file. Sorry, not Jupyter. Sorry, main file where your Streamlit code is written. My main Streamlit code in main.py file. You can change it, but I don't want to change it. And one more thing, that the Python version which you are using currently, you have to use that. Okay, and start deploy. I think there is a mistake. Cloning repository failed. Make sure the repository and the exit, and you have a entire exit. Okay. Let me see. Let me solve this problem. See, the problem is not from the from my side. Follow all the process from start, and now it's working fine. Okay, so I think the problem is not from my side. I think the problem from the Streamlit backend. Okay, now it's working fine. See, clone repository. Okay, first download the you can see the packages which is required and the packages which is present on my request.txt file. Okay, see, now it's working fine. Let me check it. This is a test directory with the unseen data. So let me select one image from no directory, means no brain tumor is present. See, it's working fine. Let me select one image from yes, random image. See, it's working fine. Now you can copy this link and go to your different browser and paste it there and start. You have to check here also so that you will get 100% surety that your model is working fine and your link is working. Let me select one image from this random image. See, it's working fine. Means your link is working. Okay. This one. See, it's working fine. It means your link is ready. You can share this link and to any, you can say any website, WhatsApp link, anything where you want. Okay, it will work. Okay, so this way it will work. Okay, so your project is ready, your model is ready, your link is ready for deployment. So your project is completed. So please subscribe my channel, comment and share and like my video so that I will get motivated to make more video like this, more knowledgeable videos for you. Okay, so please share, subscribe and like. Thanks.